welcome to GEMCHEM. Now today's video is on alkenes, part 14 video, and here we are going to deal with ozonolysis of alkenes in details. Now before starting, already 13 videos of alkenes are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. And if you are new to GEMCHEM, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. Now the word ozonolysis helps us to understand that it implies our reagent is ozone, right? O3, and this is our reagent. This reagent is electrophilic in nature, so it acts as an electrophile, and this is very important to understand. First process which occurs when ozone and alkenes react is that first thing which is going to happen is a 1,3 dipolar cycloaddition, and this part is very important, and in this whole video we are going to deal with the mechanism in details, right? After 1,3 dipolar addition cycloaddition reaction, there is a rearrangement occurring. This rearrangement part is very much important, and rearrangement can result in different products, right? And this rearrangement produces ozonides. Ozonides. What is ozonides? We will also see. And from ozonides, cleavage occurs. This ozonide gets cleaved to produce something important, that is, it can produce alcohols depending on reagent, alcohols, acids, carboxylic acids, carbonyl compounds like ketones, and aldehydes. So these are the products which can be obtained from ozonolysis. This particular cleavage step may be oxidative or reductive. Depending on that only we will get the final products. So this is a summary of ozonolysis, right? And we will deal each of the steps. So let us start. Now if you can see here, alkene is being given, and when ozone is added, this is being formed, and this is known as ozonide, right? This is known as ozonide. And if you see here, basically a cleavage occurs from in between, that is, here a cleavage occurs, and our basic first part is that here an oxygen is inserted, and in this side also oxygen is inserted, and we get R dash, R dash dash, and here we get R and H. So what is important to understand is that here an aldehyde is generated and here a ketone is generated, because here is a hydrogen. And if we add Me2S or water, zinc dust, then we get this product. But if we add H2O2, then our aldehyde is reactive and it further undergoes oxidation to produce an acid. And in presence of NaBH4, it is highly selective towards the carbon group, and it affects the carbonyl group present here to produce an aldehyde. That is, reduction takes place in this position. So here we observe reduction, and for H2O2 we observe oxidation, and this part is very much important. Reagent gets changed and accordingly product gets changed. Now as I have told you, ozone is an electrophilic reagent. So since ozone is an electrophilic reagent, it will attack a electron rich center. Remember this. Now we will see the mechanism, and this mechanism part is very important. Suppose we take like this. This is our carbon. This is our carbon-carbon double bond, right? And here we take our ozone. So ozone looks like this. Here is a positive charge and here is a negative charge. Now it will undergo 1,3 dipolar cycloaddition. So this minus will attack this center, this will attack this center, and this bond will open up, and this is known as 1,3 dipolar cycloaddition. Okay, this will result in formation of mol ozonide. So here if you see, it will be like this: carbon, carbon, here is our two bonds, then here oxygen, oxygen and oxygen. Now it will get cleaved. This particular compound is known as mol ozonide. Right, now see the cleavage. Here this comes here bond and this bond goes here. Now we get two things, that is, one is a carbonyl like this, another is like this, carbon with a positive charge and two bonds, oxygen, oxygen with a negative charge. Now we can redraw it like this, that is, if we see here, draw it like this: carbon with a double bond oxygen up and addition carbon here taken, then here is our this one O minus, and then what happens, this minus attacks the carbon double bond oxygen. We know that this is electrophilic center, so negative will attack there and it will attack here. Okay, ultimately we will get our ozonide, which is this one. See here, oxygen, carbon, carbon, oxygen, oxygen, and here is this one. Now what happens? Ultimately, depending on the reagents, this mol ozonide breaks up accordingly. But side reaction possibility always remains. What are the possibilities? Suppose this particular compound, this one, can dimerize. Okay, and dimerization can form these kind of compound. That is, here oxygen, oxygen, here is the two bonds. Another way is that nucleophilic solvent, the solvent which we use here is methanol. This is nucleophilic in nature and this solvent can react, and the reaction can result in another product which is like this. That is, here is our carbon, this is the carbon and the two groups are attached, suppose R and R dash, and we will get OMe and OOH. These are the side reactions which we can observe, and we will see one example for this particular side reaction, that is where nucleophilic attack of solvent occurs. Now remember, more electron rich double bond reacts in absence of the above electron rich double bond, and alpha beta unsaturated carbonyl compound will undergo ozonolysis. Now if you see this one, just see here, here is a normal reaction, here H2O2 added, so in this case we will get the expected acids, right, on cleavage. So what happens? Here the cleavage occurs, so ultimately we will get here double bond O, another comes here double bond O, and here is a hydrogen, here is another hydrogen. Now these two carbonyl compounds will undergo oxidation to give us the acid which we see here, OH, another comes here and OH, right. Now see here the next example, here we see that we have added ozone, then followed by NaHCO3 and Me2S, and the product comes to be different. When in the first step we are not adding the second reagent, then here nucleophilic attack occurs of the solvent, as we have seen in the previous case. So what happens? OMe attacks the positions after cleavage, that is this part which we have seen in the previous case. This particular moiety gets attacked, and here we get our this product OMe, OMe and OMe, OOH. That is what we saw here in this case, in this part, right. Now ultimately what happens? This particular thing is being removed and we get aldehyde, and here whatever is present remains as it is, because first we are seeing neutralization and then we are seeing reduction. Now for the next example, see here minutely. First of all, OCH3 is more electron donating than CH3. So the presence of OCH3 in this particular position makes this particular double bond present here to be electron rich. Okay, and CH3 though can donate electron, but this green double bond is more electron rich than this double bond present in the orange portion. So the ozonolysis will take place in the electron rich double bond. We have already seen this electron rich double bond. So as you can see here we will see the attack takes place and the product comes in this double bond. And here since presence of OCH3, so if we take this as R group, then it comes as R group, right. And since we have added at last NaBH4, so this particular position converts into OH, but NaBH4 is unable to convert the carbonyl which has an ester group, that is this is a total ester group, into the OH. So NaBH4 can transfer carbonyls into OH, but ester group cannot be transformed into alcohols. Remember this will be very important, right. Now the next example is here. That is, if you see here, this is a simple example, but the second step reagent is different. So when you are adding palladium catalyst with CaCO3, H2 and methanol, you are just doing the same thing as Me2S does or water zinc does. So we are just cleaving here and getting the carbonyl compound. Now this one is very important. This is alpha beta unsaturated carbonyl compound, and this will undergo ozonolysis and the product will be produced with 1 carbon less. Remember this. See here. If you see here, this will be cleaved, right, and ultimately we will get this product. Now what happens? Suppose this is your alpha beta unsaturated carbonyl compound. You add ozone to it. Next what happens? Here the ozone gets added. R, here oxygen, here oxygen, as previous cases, here also oxygen, and here 2 CH3s, right, and here we are left with R dash OH and here another OH. This OH means that here first water gives a proton here, right, and then this bond opens up. Ultimately the OH minus present here attacks here, so we get this part from that, right. Now we will see the cleavage. So if you can see, this OH bond breaks up, right, and it comes here. This opens up and comes here, and this bond comes in this position and this oxygen comes here. So ultimately what we get is here one, another one is that this one O minus, here double bond oxygen, plus the main product is that the acid one, which is this one. So if you see here minutely, 1 carbon here is being eliminated, another here, and another comes here, right? So this is very important and this can come in exam, right? Now we will see the next part. Now if we take a compound with 4 different groups attached, okay, if suppose 4 different groups are attached in that compound, that is R1, R2 and here R3 and here R4. Then when ozone is being added in inert solvent, what happens is that we will get a mixture of ozonides, mix of ozonides. And you have to tell me what are the structures of the possible ozonides. Okay, first try, then I will answer. Pause the video and try for 1 second, then I will tell you the answer. Now see, first of all we will draw the mole ozonide coming from here, right? So this is very important. This is oxygen, this is oxygen, this is oxygen. Here we will get R3, R4, R2, R1, right? Now this can cleave in 2 ways to give us 4 products. What are the 4 products? See here, one is this one, having this positive charge, R1, R2, plus this one along with this R3 and R4. This is one. Another possibility is that it can have R1, R2, double bond oxygen and COO minus and here R3, R4, right? Now we will number them. So we will take this one A, this one B, this one C and this one D, and their different combinations will give rise to different mole ozonides. So in the next part we will see that if suppose A and C combines or B and D combines, we will get this structure. This one, here oxygen, oxygen, R3, R4, R1 and R2, that is having 4 different substituents. If suppose this happens that A and D combines, then we will get this kind of structure, that is having R3, R4 and here also R3 and R4, right? And if suppose similarly B and C combines, we will get here R1, R2, oxygen, 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 R1, R. Okay, this particular mole ozonide in the first place has 4 isomeric forms. 4 isomeric forms are possible for this one. Okay, that is, it can exist in 2 diastereomeric forms, that is cis and trans. And if we see for the next part, then for this one we have 3 possible mole ozonides, cis and trans taken together, of which trans isomer can exist in 2 enantiomeric forms. Okay, so it has cis and trans have a enantiomer. So we are having 3 structures. And what is cis, what is trans, what are diastereomers, what are enantiomers, we have already discussed in the stereochemistry video, so you can watch it. I will give the link in the description box as well as the I button present above this video. Here we will have cis and trans and each will have enantiomers. Each will have enantiomers, so we will get 4 structures. And the last one which we see here will have 3 possible structures. It will have cis and trans, and the trans will have 2 enantiomeric forms. Okay, so we will have 3 structures. So ultimately, what is the number of mole ozonides which we are going to get is total 4 plus 3 plus 3, that is total 10 mole ozonide possible in this mixture. And this is very important question. Question can be framed in many different ways. So this much for today. From the next videos of alkenes, we will deal with advanced topics, and also we will deal with dialkenes. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment.